Top 25 GitOps Interview Questions and Answers. GitOps is transforming modern infrastructure and deployment workflows by combining Git-based version control with declarative automation. These questions help demonstrate practical experience, core concepts, and real-world implementation knowledge. 1. What is GitOps and why is it important? GitOps is a methodology that uses Git as the single source of truth for infrastructure and application configurations. It enables fast, reliable deployments through automated reconciliation. GitOps improves collaboration, reduces human error, and enforces version-controlled workflows. Its declarative approach ensures predictable environments. This method aligns DevOps processes with modern cloud-native principles, simplifying rollbacks and audits. GitOps is essential for scalable, automated, and secure infrastructure management. 2. How does GitOps differ from traditional DevOps? GitOps differs from traditional DevOps by making Git the central control mechanism for all environment changes. Traditional DevOps uses C pipelines and manual changes, while GitOps relies on declarative configurations and reconciliation loops. This removes configuration drift, increases traceability, and automates delivery. GitOps emphasizes pull-based deployments instead of pushing changes. It also promotes security and rollback simplicity. Overall, GitOps provides more consistency, predictability, and automation. 3. What are the core principles of GitOps? The 4 core GitOps principles include declarative system definitions, Git as the source of truth, automated reconciliation, and continuous operations through event-driven workflows. Declarative files describe desired states, while Git manages version control. Automated agents compare current versus desired states and fix drift. This ensures consistent, reliable infrastructure. These principles strengthen auditability, rollback capability, security, and development productivity by reducing manual intervention and enforcing configuration immutability across environments. 4. What tools are commonly used for GitOps implementation? Common GitOps tools include Argo CD, FluxCD, Jenkins X, Tekton, and Git-based platforms like GitHub or GitLab. Argo CD and Flux serve as Kubernetes controllers that continuously reconcile desired states. Jenkins X automates CI/CD with GitOps patterns. Tekton provides pipelines for event-driven deployments. Combined with Git, these tools create automated workflows, ensure consistent updates, and maintain environment correctness through declarative configuration and continuous monitoring. 5. How does Argo CD work in GitOps? Argo CD continuously monitors Git repositories for configuration changes and reconciles them with the Kubernetes cluster. It pulls desired states from Git, compares them with actual deployments, and applies updates when differences exist. It supports automated or manual sync. Argo CD provides dashboards, RBAC, webhooks, and rollback capabilities. The tool simplifies multi-environment deployment and ensures consistent, reliable infrastructure. It is widely used for cloud-native applications and Kubernetes automation. 6. What is a reconciliation loop in GitOps? A reconciliation loop automatically compares the actual cluster state with the desired state in Git. If differences are detected, the loop corrects the environment to match Git. This eliminates configuration drift and provides continuous compliance. Reconciliation occurs periodically or via event triggers. Tools like Flux and Argo CD perform this process. It ensures self-healing, reliable deployments, and predictable infrastructure. GitOps relies heavily on these loops for automation. 7. What is configuration drift and how does GitOps prevent it? Configuration drift occurs when real infrastructure diverges from the intended configuration. GitOps prevents drift through continuous reconciliation loops that enforce Git as the source of truth. Whenever unauthorized or accidental changes occur, GitOps tools automatically correct them. Version control ensures every change is documented. This improves reliability, reduces errors, and maintains consistent environments. By removing manual updates, GitOps delivers predictable deployments and strong operational stability across environments. 8. What are the benefits of using Git as the source of truth? Using Git as the source of truth centralizes configuration, enables auditing, and enhances collaboration. Every change is versioned, reviewed, and traceable. This improves security and accountability. It simplifies rollbacks because earlier states are easily restored. Git native workflows encourage pull requests and peer review. Using Git also integrates seamlessly with automation tools. Overall, it enforces consistency, reduces errors, and creates predictable, secure environments ideal for modern DevOps workflows. 9. What is declarative configuration in GitOps? Declarative configuration defines the desired final state rather than specifying step-by-step instructions. GitOps uses YAML manifests or similar files to describe infrastructure and applications. Tools compare actual states with these desired definitions to ensure alignment. Declarative systems are predictable, repeatable, and easier to manage. They simplify audits, rollbacks, and scaling. Declarative configuration removes the complexity of imperative scripts and allows GitOps to deliver automated, controlled cluster management. 10. How does GitOps improve security? GitOps improves security through centralized version control, strong audit trails, and Git-based approval workflows. All changes pass through pull requests, reducing unauthorized modifications. Immutable history increases accountability, while reconciliation loops prevent configuration drift. GitOps reduces direct cluster access, lowering security risks. It also supports RBAC, SSO, and secret management integrations. These practices ensure controlled, traceable changes that strengthen security and compliance in production environments. 11. What is the difference between push-based and pull-based deployments? Push-based deployments send updates from CI pipelines directly to clusters, requiring elevated permissions. Pull-based deployments, used in GitOps, have controllers fetch desired states from Git. Pull-based methods reduce security risks, eliminate manual updates, and support self-healing. The cluster continuously checks Git for changes. This makes deployments more reliable and predictable. Push-based systems rely heavily on CI, whereas pull-based GitOps uses reconciliation loops for automated state enforcement. 12. How do GitOps pipelines work? GitOps pipelines trigger deployments based on changes pushed to Git repositories. Developers update configuration files, create pull requests, and merge changes. A GitOps controller detects updates and applies them to the environment. Pipelines enforce automated testing, validation, and approval workflows. Continuous reconciliation ensures compliance with the desired state. This model simplifies deployments, increases predictability, and reduces manual steps. GitOps pipelines integrate with CI tools and Kubernetes automation processes seamlessly. 13. What challenges can occur with GitOps adoption? Challenges include complex learning curves, inconsistent repository structures, and misconfigured automation. Large-scale environments may struggle with repository sprawl. Secret management can add difficulty. Teams may resist new workflows. Dependency ordering and multi-environment promotions require planning. Without proper governance, GitOps can introduce security gaps. Scaling GitOps needs strong standards, monitoring, and training. Addressing these challenges ensures smoother adoption and sustainable long-term success. 14. How do you handle secrets in GitOps? Handling secrets in GitOps requires encryption or external secret stores. Tools like Sealed Secrets, SOPS, and HashiCorp Vault integrate seamlessly with GitOps workflows. Secrets should never be stored unencrypted in Git repositories. Controllers decrypt sealed files only within clusters. External secret managers provide dynamic retrieval. Strong access control protects credentials. This ensures secure automation without exposing sensitive data. Proper secret management is essential for safe GitOps implementation. 15. What is a GitOps workflow? A GitOps workflow includes declaring desired states in Git, reviewing pull requests, merging changes, and allowing controllers to reconcile environments automatically. Developers propose updates through version-controlled processes. GitOps tools monitor repositories and apply changes when detected. Continuous reconciliation prevents drift and ensures predictable deployments. Automated rollbacks, auditing, and monitoring support stability. The workflow promotes collaboration, reduces risk, and strengthens deployment consistency across multiple environments. 16. How does GitOps support rollbacks? GitOps supports rollbacks by leveraging Git's version history. If an issue arises, teams revert to a previous commit, and the controller applies that configuration automatically. Rollbacks become simple, fast, and reliable. No manual cluster intervention is needed. Declarative files guarantee consistent results. This reduces downtime and improves recovery speed. GitOps rollbacks are predictable and allow teams to maintain operational stability while troubleshooting the root cause of failures. 17. How do you structure Git repositories for GitOps? Repository structure varies, but common patterns include environment-based, application-based, or mono-repo approaches. Separating production, staging, and development repositories improves security. Application store manifests or Helm charts. Infrastructure code is versioned separately. Clear folder hierarchies simplify automation. Consistency is essential for maintainability. Good documentation, naming conventions, and branching strategies help teams collaborate effectively. The goal is to ensure clarity, scalability, and reliable automated reconciliation across environments. 18. What is the role of pull requests in GitOps? Pull requests enable controlled, peer-reviewed changes to infrastructure and applications. They introduce collaboration, validation, and approval steps before changes reach environments. Git history captures all modifications for auditing. Pull requests prevent unauthorized updates and enforce security policies. They support automated testing and integration checks. This ensures changes are deliberate, reviewed, and traceable. In GitOps, pull requests form the foundation of safe, predictable deployment workflows. 19. How does GitOps improve observability? GitOps improves observability by providing clear visibility into configuration states, change history, and deployment events. Git logs track modifications, while tools like Argo CD offer dashboards for application health. Continuous reconciliation detects drift automatically. Metrics, alerts, and event streams enhance monitoring. Observability helps teams troubleshoot quickly and maintain stability. GitOps ensures consistent, auditable states that support reliable operations and easier debugging through clear configuration management practices. 20. What is multi-cluster management in GitOps? Multi-cluster GitOps manages multiple Kubernetes clusters through centralized Git repositories. Each cluster is reconciled based on environment-specific configuration files. GitOps tools ensure consistency across clusters while enabling customization. This approach supports scaling, high availability, and workload distribution. Multi-cluster GitOps improves visibility, standardization, and automation. Teams can manage production, staging, and development clusters efficiently. It simplifies operations and ensures predictable behavior across distributed environments. 21. How does GitOps enhance collaboration between teams? GitOps enhances collaboration by using Git as the shared platform for infrastructure and application changes. Developers, operators, and security teams review and approve updates through pull requests. This improves communication and reduces misalignment. Version control ensures transparency and accountability. Shared automation processes remove silos and encourage consistent practices. GitOps promotes shared ownership of deployments and environments. It strengthens coordination and accelerates delivery across teams. 22. What are Kubernetes manifests in GitOps? Kubernetes manifests are YAML files that define desired states for clusters, including deployments, services, and configurations. In GitOps, these manifests serve as declarative instructions stored in Git. Controllers monitor repositories and apply changes automatically. Manifests enable predictable, repeatable deployments. They support version control, rollback, and auditing. Using manifests ensures consistent environments, simplifies configuration management, and allows teams to scale applications efficiently through GitOps workflows. 23. How do you test changes in a GitOps workflow? Testing in GitOps involves validating configuration files, running automated CI tests, using policy as code tools, and deploying updates to staging environments before production. Pull requests trigger checks that prevent invalid configurations. GitOps controllers apply changes safely to test clusters. Canary deployments, linting, and integration testing ensure reliability. Continuous testing reduces risk and increases confidence. Proper testing ensures stable, secure, and predictable deployments in GitOps environments. 24. What are the best practices for GitOps deployment? GitOps best practices include maintaining clean repositories, enforcing pull requests, using declarative configurations, encrypting secrets, applying RBAC, and enabling automated reconciliation. Clear documentation and naming conventions are essential. Separate repositories improve security across environments. Observability tools monitor changes and health. Follow least privilege principles. Ensure proper testing workflows before merging. Adopting these practices ensures scalable, secure, and maintainable GitOps workflows that support reliable automation. 25. What future trends are emerging in GitOps? Future GitOps trends include enhanced AI-driven automation, policy as code expansion, multi-cloud GitOps adoption, and improved security integrations. Tools will offer deeper observability, secret rotation, and compliance capabilities. GitOps workflows will become more standardized across enterprises. Integrations with serverless systems, edge computing, and WebAssembly will grow. These advancements will accelerate DevOps efficiency, increase reliability, and strengthen global scalability, making GitOps essential for modern cloud operations. GitOps continues transforming application delivery with automation, security, and reliability. Mastering its principles, workflows, and tools empowers teams to build scalable, consistent, and future-ready cloud-native environments.